Module 1, Lesson 24, Triangle Congruence by Side, Side, Side. In this lesson, we are going to prove triangles congruent using 3 corresponding sides. Thus, the side, side, side postulate. If 3 sides of one triangle are congruent to the 3 sides of another triangle, then the 2 triangles are going to be congruent. Now let's take a look at our diagram. So we have if segment AB is congruent to segment DE and segment BC is congruent to segment EF and segment AC is congruent to segment DF, then we will be able to say that our triangles are congruent. Now notice, when we write our congruence statement, we go along side 1 and then down side 2. And so in the second triangle, we go along side 1 and then down side 2. So we can say triangle ABC is congruent to triangle DEF. And notice when we write our segment congruence statements, that they are in the appropriate order. We are going from A to B and D to E. Now, the side, side, side postulate is probably the most logical postulate when we're given rigid figures. If you have 3 toothpicks of the same length, you will always build exactly the same triangle. If everyone has the same 3 size toothpicks, everyone will build a congruent triangle. So side, side, side is pretty neat. Let's look at a proof here using side, side, side. And we look at our diagram, and I see that we have 2 congruent sides here. That is just given to us. And we have 2 congruent sides here. Again, just given to us. And I see a common side to them, so that's going to be our reflexive property of congruence. And look, we have 3 congruent sides in our triangles. So this is going to be a very simple proof. Here's our first side. There's our purple side there. And our second side. There's our blue sides there. And notice when we are writing our congruence statements, make sure that they are in the proper order. And our third side, our green side there, is the reflexive property. And then we simply write our proof. Side, side, side postulate shows that triangle LMN is congruent to triangle NPL. Along side 1, up side 2. So that means on this one we need to go along side 1, down side 2. So LMN, NPL. Make sure everything is in the appropriate order. Now we are also asked to determine what rigid motion would map one figure onto another, and we have seen this before. Easiest one probably would be to simply rotate 180 degrees about the midpoint of segment LN. So we would rotate that one up and all of our corresponding parts would match up. Now if we wanted to look at possible compositions of transformations, one that we have seen before, we would simply take one of our triangles and translate it along the length of that common segment there in the middle. And then we would rotate 180 degrees about point L, and the figures would map onto each other. Again, there are many different possibilities that you could do as combinations of transformations. Thank you, geometry. Many ways to get to the same answer. And of course, we're going to look at a proof using our corresponding parts of congruent triangles, CPCTC. And what do we see here? I see that we are given congruent sides. We also have a common side, which will be our reflexive property of congruence. And what else do we know? Ooh, M is the midpoint. Midpoint means we're going to have two congruent parts. Midpoint of segment BC. And so that is going to let us mark these two segments congruent by definition of midpoint. So when we do our define, explore, and I see side, side, side here. Do you see the three corresponding sides, congruent sides? Our first side is just our purple side, and notice we go from A to B and A to C, and that order matters. And then we have our next side here, our red side, is by midpoint. We are given that M is the midpoint. Midpoint. That's just given to us. And then we can say that our side is congruent by definition of midpoint. And our third side, our blue side, is the reflexive property of congruence. So when we write our proof, we have our first side, which is given to us, and then our second side here requires two steps. We are given that M is the midpoint, and by definition of midpoint, we can make our segments congruent. And then our third side is the reflexive property of congruence, and that lets us say that triangle AM, we go down the common side here and over to B. So we're going to go down the common side and then over to C. So AMB is congruent to triangle AMC. And we want to prove that angle AMB, this angle right here, is congruent to this angle right here. And that is easily done because corresponding parts of congruent triangles are congruent. We could also prove that angle MBA is congruent to angle MCA. That would be those points there. We could also prove that angle BAM is congruent to angle CAM. And those would be the ones up here at the top. Now look at your triangle congruence statement. All of these things that we have written here that follow CPCTC follow the order of our congruence statement. Our first angle, we started with AMB and went AMC, so that matched up nicely. The second set of angles that we looked at here started in the middle, MB, and back around to A. So we start in the middle and go MC, back around to A. And this last set of angles we did started at the end, B, and then back over to AM. So it goes C and back over to AM. Your congruence statement tells you everything that you need to know. And make sure that you are defining and exploring and labeling your diagram, because that is going to make everything so much easier. And don't forget, geometry is easier in color. I hope that you enjoy. doing proofs using the side-side-side postulate.